Alright everyone, last lesson for the week. Woohoo! We're doing the quadratics section, part 2. So the bottom two examples on the notes we took yesterday. Just splitting it up a little bit so that you guys don't have so many of those problems to do in one day. You will need to finish that worksheet on the back side for today once you've viewed this lesson though. So pretty similar to what we were doing yesterday. Like I said, with these quadratics, elimination really isn't an option you should try. You should focus on doing substitution. It just tends to work out better that way. So that whole group, I can actually replace the y with here, just like we talked about yesterday. Now some of you might be saying, well, why do I have to watch these examples if it's just like it was yesterday? Hold your horses, because it's not exactly like it was yesterday. Okay, so just chill out if you're thinking that. Okay, so that's our first step. All I did was replace y with that group, and I'm talking about that first equation again. Remember we talked about yesterday, we're trying to get it to equal 0, so I need everybody to move to one side. Nicely enough, though, these two are going to cancel out for us, so I can just get rid of those. I don't know why I did it that way. So now I have x squared plus 1 equals negative 1. That means I got to move this 1 over here, because like I said, got to make it equal the big 0. All right. Now we talked about your goal is to be able to factor it. That would be ideal if everything was factorable. That's not always possible. We'll try it out with this one. Remember, if there's nothing in the middle, it's really a 0x in reality. Okay, so does anything, well, first of all, what are my factors of 2? 1 and 2, that's really it. Okay, well, 1 times 2 is 2, but can I add or subtract 1 and 2 to get 0? No, I can't, which means factoring is a no-go for this one, unfortunately. So go to your next option that we had. Remember sorry for that interruption. A couple slides ago I was saying we had a few options that we talked about. Factoring obviously isn't going to work. You could try to complete the square, but I really would not suggest that, especially because we have a 0x in there. So let's kind of backtrack. I'm going to bring this guy down here. Maybe you guys saw it at the beginning. Is there another way I could get x solved for? Since I only have x squared plus 2, can't I just move the 2 away from the x and solve for x? Why, yes, you can. When you can't factor, see if you can get to be solved by square roots. That means that there's no x term, though. If I, for instance, had x squared plus 5x in the middle, plus 2, then no, I can't do this option. Okay, I'd have to skip and go to either complete the square or quadratic formula. All right, in my case, though, I can try this. How do I get rid of squaring? Well, I take the square root. Remember, I kind of talked about that in the other example. Now, the problem here is this. I do get a plus or minus, but look at this right here. What happens because I have a negative in the square root? That little letter pops out. Now, that letter stands for what type of numbers? Imaginary numbers. Okay, which means if I think about this as a graph, if the only answer I get has an imaginary number in it, are these lines ever going to cross? If I can't get a real number, the answer is no. Right? So anytime you see this, that means your only answer has imaginary numbers, which means there is no real, and you have to use the word real. I'm talking about real numbers. Real numbers are things that are not imaginary numbers, so numbers we're used to using. But it means there are no real solutions. There is an imaginary solution. It's plus or minus I squared root of 2, but since we're talking about graphing, we're really not concerned with the imaginary solutions. It just doesn't work. All right, so at that point we would stop with that one. I'm also going to show you real quick that you could solve this with quadratic formula. You're going to have an example in your practice problems where you're not going to be able to factor and you need to use quadratic formula. Remember that formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Yes, you need to memorize that. Okay, so we're going to use this guy to plug in for quadratic. We're going to get the same answer I just did. Yes, I know that seems redundant. You need to watch this, though, because you need to know how to do quadratic formula. It's a good refresher for you guys. So x squared really has a 1 in front. There's really a 0 in the middle. And then there's a 2. That means that my a value is 1. My b value is 0. And my c value is 2. And you're going to see pretty quickly how this works out with quadratic formula as well. It's going to make sense pretty soon. So in the front I have negative 0, which is still 0. Alright, and we got plus or minus the square root of b squared, which is 0 squared, minus 4. And then a and c are going to go in those spots. And 2a goes on the bottom. So a is going to go there and there. C is going to go here. Again, all I'm doing is plugging into quadratic formula. Just want to give you a quick refresher. We know it should end up with no real solutions, but we're going to watch this anyway. Simplify it out. 0 plus or minus 0 minus 4 times 1 times 2, which is 8. All over 2. And some of you might already see what our issue is going to be. It's that guy right there. There's that negative in the square root. Automatically, you get a negative in the square root, you're going to have a letter I somewhere in your problem. Automatically a not real solution type problem. Alright, so 2 routes you can take. On your homework, I'm going to tell you right now, there is one that's not factorable, so you might have to check by quadratic formula to see if you can work it out that way. Alright, and let's go back really quick, sorry. If we look at the graph, you can see how they don't actually cross. That's what I'm telling you guys, is that if you have imaginary numbers, there's not really a place it's going to cross. It just won't happen. Alright, so let's move on to the second example. Same idea, got a substitute. What does y equal? It equals this whole group. Plug it in over there. Would not be a bad idea for you to pause right now and try it out yourself, because you probably could. Pretty similar to the other ones we've done so far. Gonna have to do a little bit of work to solve it. Okay, remember to combine your like terms. Get everything over to one side. You're trying to get it to equal 0. I know that's kind of weird because we just spent time doing linear stuff where that wasn't necessarily the case, but this time it is. So I have x squared, negative 2x and negative 1x really. It's negative 3x, and then I still have this plus 1 in there, and it still equals negative 1. Let's get this negative moved on over. Get rid of that. There's my big 0 I was looking for. X squared minus 3x plus 2. Okay, feel free to pause. If you're not understanding this or you're very confused, raise your hand to ask. Do not just blindly go through the video just to get it done. Ask for help. Remember I said check to see if you can factor it first. It's always your first goal. It'd be awesome if everything was factorable. Only numbers are 1 and 2. Okay, we're looking good so far. Does 1 and 2 add to 3? Well, yes it does. Okay, doing good. Let's see if our signs are going to work out. Obviously I have x and 1, x and 2. Alright, well I need to multiply to be a positive 2. So that means it's either plus 1 times positive 2 or negative 1 times negative 2. Trying to get a negative 3 though. So they both must be negative. Awesome. It worked out to factor it. That's awesome. Solve it for x, just like we did yesterday. Good refresher on the material we learned then. Can't just stop once it's factored. You have to actually solve it. Yes, I know that's a lot of extra work. I am aware. And do both sides. So we get that x equals 2. Again, feel free to pause here, rewind, hear it again, whatever you need to do. We are not done yet though. These are both x values. I need to solve for the y values. So much work to do, I know. All right, go back up to the original. I'm going to pick that first equation because that looks super easy. So I'm going to memorize that. Y minus x equals negative 1. All right, so over here, I'm going to plug in positive 1. So y minus 1 equals negative 1. Solve for y. Solve for y. All right, well, y equals 0 for that one. All righty. And over here, y minus 2 equals negative 1. Add to both sides. Add to both sides. So y equals positive 1. All right, looking good so far. Okay, now I still have to write them as coordinates. Hopefully you remember that. So when x is 1, y is 0, that's 1 point. When x is 2, y is 1, that's my other point. So this one has 2 solutions. You need to write them out like that. They're going to be written like that on your CBA and ACT and all those other fun things. Let's check up back at the top. 1, 0, and 2, 1. Let's make sure that that's actually our answer. Hopefully Mrs. Crawford did it correctly. Okay, good. I did. There are your 2 answers. You can see that that's exactly where it crosses the graph at. Again, feel free to rewind, ask for help. There's plenty of teachers in the room that you can ask if you need some help understanding this. This is a tough section. Make sure you watched all of part 1 and all of part 2. And then do the problems on the back of this worksheet. That'll be due on the Monday that we come back from our little mini break. And I hope I see you guys and your parents at parent-teacher conferences this weekend.